Hello, I'm Nobby. Welcome to my workshop. I'm going to start another little project which I hope I can complete in one afternoon. You can see from the title of the video what this is going to be, so I hope this is going to be an interesting one for you. I won't be talking for the first part of this because you'll see me actually dismantling one of the parts I'm going to use, but beyond that I'll explain what I'm doing as we move along, and then at the very end, hopefully if it all works, actually demonstrate the item in use. So I hope you stick with me and I hope you enjoy it, so let's dive into it straight away. Hello, it's a little project here which you saw me start. It is to make an electronic edge finder for the milling machine. Now this is not my idea. I'm copying this one from the one that Myfordboy made. It's a very recent video he put up, I think only a few weeks ago, so do have a look at the Myfordboy channel to see how he made this edge finder for his little CNC machine. So I hope you don't mind, David, that I'm copying what you're making here. Now, the reason I'm making one is that I do already have an electronic edge finder. It's one of these, which I'm sure a lot of you have seen already. This one gives you a visual and an audible signal when the ball on here touches the item that's mounted in the mill chuck. If I put that across here, you'll see a little light comes on and you'll hear an audible signal as well. It's a little red light and an audible signal. Now the only real problem with this is that the for some situations the ball on here is too big. The ball on here measures well, a nominal 10 millimeters. The other couple of problems are that this is quite long. This from memory is about 6.5 or so inches long, and the body of it here is 20 millimeters across. It takes inside here there's a couple of little batteries. I always, when it's not in use, I always remove the batteries when I store it away, because it's only used sort of very intermittently, really. These are not expensive, oddly enough. They're a beautiful looking thing, but I think from looking at these on eBay most recently, they were sort of £14–15, which I think is incredible value, really, for something like this. I mean, I've had this one since the beginning of 2023. Oh, and I noticed I've written on the inside of the box here, if you can see that, there we are, the 7th of February 2023, eBay, and I paid £12 for it then, but they are sort of a couple of pounds dearer now. It stores in this nice little box. The batteries go in here. Now the ball on this, I say, was a nominal 10 millimeters. If you can see it, these are the actual sizes. It's actually 9.98 millimeters, or 0.3930 in inches, and the measurement next to it is you can obviously work this out in your head, but that's half that measurement, because some situations you've got to half the diameter of the ball here where you're doing your calculations for various functions with your DRO in this nice little sort of hinged box. Let's put that on one side. So what I'm aiming to make is one of these with a much smaller diameter probe for working with smaller pieces of material where I can't get that 10 millimeter probe in the chuck where small items are mounted in it. I'm just going to make the probe out of probably, I think this will probably work, just a piece of round bar. I think this probably will do the job for me. This is a nominal 4 millimeters in diameter, so I think that will do. We'll probably only need a piece about half the length of that. Now the thing is that I think on the one that Myfordboy made for his little CNC machine, that the vise is actually insulated from the base of the CNC machine. Now with this, it on my milling machine obviously it isn't, and to use the big edge finder I use, it's using the whole of the milling machine as one of the contacts, and I'm guessing that on this one it has some sort of insulation inside to stop this, but I presume inside here the ball is insulated from the body of this, so where it touches the object it's making contact through here and here. I'm guessing that's how it works. So I've got to do something in a similar way, because if I put this on the sort of somewhere on the milling machine, and then I connect one of these wires, where's the other end of this gone? There we go. If I connect one of these wires to this, and the other end of the wire to that, the little light's going to go on. Let's make sure it does actually do that. So if I put one wire on there, it's going to go on. So what I've got to do, I reckon, is insulate this piece, so that where this goes into a drill chuck or a collet chuck or something like that, I've got to have some insulation on the top. Now what I've found, the only sort of accurate round plastic I've got is this piece of acrylic bar. Now this is a very, very accurate sized material, so what I'm going to do is cut a piece of this off and just drill through this so that bar can go through there to give me the necessary insulation. That I said was 4mm. I think this is, I think it's 10. Well, yeah, it's a nominal 10mm, 9.92. So I think that will do. I don't think I'll need to turn this down, because I've got a 10mm collet that I can mount this into on a Morse Taper 3 collet chuck. So that's what I'm going to do next, is machine the end of that off flat, and then drill through that either right the way through or part way through 4mm, and then just cut a piece off, and that should complete the job actually. So I'll do that, and then we can do some testing on it. Again, do take a look at Myfordboy's channel to see this, because this is his idea. And obviously I've probably done it a little bit different. You probably noticed that to attach one of the wires to one of the prongs of the LED, I just wrapped the wire around it. I'm going to later on solder that on, and I didn't want to do that immediately just in case it didn't work. And the other wire I've just laid across where it would make contact with the battery, mainly to possibly tin that, just so I get a nice contact with it. I mean, these little LED tea lights are very, very inexpensive to buy. I bought a little box of these. I think it was 5 in a box for £4 in a local shop. I mean, they are available on eBay, and you can buy them in various quantities. But of course, buying it on eBay, they factor in postage, so 1 or 2 would probably cost you that much money. So I'm sure that near to wherever you live, there's going to be a shop somewhere, that call it a corner shop or something, that sells these. So very easy to buy, and quite a nice little project actually. So I'll bring you back when I'm sort of doing this part. I've got a piece of that acrylic bar mounted in the lathe chuck here. I've already faced off the other end and just broke the edge of the other end, so I've turned it round. So I just need to clean up this face here. It's very strange stuff to cut on. I remember machining some of this some time back, and it's a peculiar material to machine, but It's quite nice, the machine, actually. Let's see, we've got that completely cleaned up. It's a bit of a job to see, actually. It's going to use my magnifier so I can a bit closer. What? I think that's all right. Let's move that back a bit more so I can see the end of it. Yep, that looks all right. What we'll do is we'll break the edge of that as well, give it a, well, it can have a sort of a decent chamfer on the edge of that. Switch tools over. Alright. Yep, I think that's right. You get the most peculiar chips from it and they stick to your fingers and everything. Right, let's take that tool out of the way and we can set up to drill our 4mm hole in there. Go with the centre drill first. Make sure we clear everything there. There we go. A 4mm drill. Probably drill it all the way through. It's an interesting thing to watch because being sort of transparent, you can actually see what the drill is doing, which is quite novel. It's quite cool actually, because it's magnifying the drill as well, and it's melting the material as well. You see, building up quite a bit of heat in there. That's it, that's broken through. You see it's melted the material. Let's move that out of the way. I hope so. It's going to work all right. Right, we've got our 4mm hole drilled through here. And the bar should go, well, I think with a bit of encouragement that's going to go into there. I won't push that in there just yet because was already cut beautifully to length, so I want to put this in the chuck and then just make sure I don't think there's any sharp edge, but I'll just break the edge on that nicely, and then that can be mounted into there. Well, there's our part. It was fun actually seeing the drill go through there, because you can actually see all the cutting action. I've seen something like that before. I remember watching an instructional video on drills, and it was actually done as a sort of not like a cartoon, but in similar way, showing how drills cut. But I think with just a bit of encouragement, I can get that to go into there quite nicely. But first I'll just gently put a file across the end of this to make sure there's no sharp edges on it at all. I don't think there is. I think, I'm not quite sure with this, I think this is stainless steel. I was given some little boxes of bar of all different diameters in aluminium and in stainless steel. Yes. Just that really just to make sure there's no sharp edges on that, because that obviously would make a difference to any readings actually. I think what I will do is turn this round in case I forget which end I filed up. Let's turn it round the other way and do that end as well. That's it. Now I take that out. Okay. Right, so now I can probably set all this up now, and we'll give it a test, shall we, and see how we've got on with it. But we're all set up on the milling machine. I've got the probe mounted into that piece of acrylic material in a 10mm collet, in my ER32 collet chuck. I've just propped this on the top here so you can see what's happening. One wire I've got just with a crocodile clip onto the bar here, and the other one, which you can't see, but it's down here. I've got it. The crocodile clip won't open up wide enough to go round the bolt that fixes this to the table, so I've just got it clamped onto the washer underneath. So I'm connected to, basically this one connects me to the milling machine, and this one, which is insulated, connects me to the probe itself. I'm pretty sure, looking at it now, that I've made this probe far too long, because there's obviously there is a slight movement in that. Obviously if you bring this in very, very gently, it probably will be okay, but I think really I need to sort of cut this at least in half, so that it's less likely to flex. But for this experiment, I'll leave it as is, and then later on I'll just chop this off, so that I don't really have that problem. But I've got to very, very gently bring that in against the edge of the vise here. I'm not going to bother to put any material in here to do it. You can just about see the probe on the side of the vise there, so that's going to be good enough, and I can bring that in as gently as I possibly can until the little LED lights up. There we are, that's lit up. So on my DRO, what is that? I already tested this. It's come up to all zeros on X. So I'll wind that out again and bring that in again and see if I get near to the same reading again. Well, it's oh yeah, it actually showed 5,000, but now it's gone back to all zeros again. Let me see if I can bring the camera around. Let's do an experiment and see whether you can actually see what I'm doing here. So if I bring that down, yeah, and you can see we've got the probe against the edge and and the little lights on. And if I can turn that up to, this is not going to work. Let's bring the DRO round so that you can hopefully see. Yeah, you can just about see it. It's slightly out of focus. Let's do that. So you can see on X I'm on all zeros there. Now I'll take that out again and I'll bring that up to get the little LED to come on again very gently and see how close I am. Right, that's on. Which it's reading 10,000 that time, so it didn't repeat terribly well. And well, this time it's on all zeros again up here. That second reading I did, there may be that the bar did flex a bit and pushed it around to 10,000. Let's bring that back down again. So within, I think if I do shorten that bar, that might improve things. So that will be the next stage. I'm pretty confident that will work. So I think as an experiment, this has worked quite well actually. Let's bring that out so that the little light goes out. Obviously with the wire itself, well, that doesn't really matter really, because once you've got this set up, you just remove all of this out of the way, as you would with the other edge finder I've got. You just remove that and then you set your machine up for a machining operation. So this may not look really neat. I've just literally these little screws that hold the wires onto here. Obviously I can make a better job of that so that they're a bit more permanent on both of them and solder up inside here properly. But I think this is pretty good actually. So I know that when Myfordboy tested his, he got very good repeatability on his one as well. So I'm quite pleased with it actually. And this was fun to do. Again, another little very late afternoon project. The weather's been horrible today. It's been raining on and off all day. So I waited till, I think it was about 2:30 in the afternoon. I came out to the workshop and started doing this, and I've just sort of carried on until I've completed it. So it's quite good. So I've actually spent quite a few hours doing this, but it's all the fiddling around and of course trying to set up to film it as well. Well, I hope you've enjoyed this, and it's obviously a very, very inexpensive way to make yourself an edge finder. I mean, I obviously had to buy the little tea light, which was very inexpensive. The ones that are left over, obviously we can use around the house somewhere or whatever, or give them away or whatever, I don't know. I already had the little bar, I already had the little bit of acrylic rod the bits of wire are just scrap bits of wire I found. I try to find the thinnest bits of wire I've got. The little crocodile clips, I already had a little pack of those from other old projects I'd done in the past. So apart from the tea light, I haven't really had to buy anything at all for this. So thank you, Myfordboy, David, for suggesting this. I think I sent him a comment saying we was going to have a go at making one of these. And this is going to be very useful, as I mentioned, that when you've got very, very small pieces of material in the mill chuck here and you want to sort of find a centre or whatever, that's larger edge finder I've got, just for lots of situations, just won't fit. So this is going to give me another really good option for edge finding as well. I was worried that where the little LED comes on, it says this is a flicker LED, and there is a sort of sign that happening that wouldn't sort of come on accurately enough, where there would be a sort of a bit of a time delay. But I think if I shorten this rod to make it stiffer, I probably won't have that problem. And certainly I did get repeatability on it. Obviously I'd have to sort of experiment with that a little bit more, but I think that's worked quite well. Anyway, thanks for joining me in the workshop. This is Nobby Clark saying thanks for all the subscribers to the channel, and I hope some of you make one of these, or have already made something like this in the past. So send me a comment what you think of this. So there we are. It's goodbye from me, and I'll see you in the next one.